Hello everyone, welcome back. I will introduce a new humidity and temperature sensor that will be SI7006-A20, and for that we need to log into website that will be controleverything.com, and here after we have the sensor as you can see on my screen, and let's proceed further. And we have the sensor which is a humidity and temperature sensor, and also some more features onto the screen. You can also purchase the sensor from this website right from here. Also, I will be interfacing the humidity and temperature sensor SI7006 with a BeagleBone Black, and the concerned code will be in C language, and for that we go to resource tab, and here we have the C code sample onto the screen. After that we can download the code as a zip file from here. Also you can get the code from github.com, and the repository there will be control everything community. Now let's have a look over the hardware connections we need for this video tutorial, and let's proceed. Well, for the hardware connection setup, the first thing we require is the BeagleBone Black, which you are able to see on my screen. And this here is an I2C Shield for the BeagleBone Black. Now this is available on the website controleverything.com, and the real reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this I2C Shield over the BeagleBone Black and make a connection just like that. For the power up setup, we require two things. The first is a mini USB cable just like this, and gently insert it over here. It is very useful to power up the BeagleBone Black. Now to power up the I2C Shield, we require a 5-volt adapter, which you are able to see on my screen, and gently insert it here. Now for an option for the internet connection, there are two mediums. The first is an Ethernet cable or a LAN cable, and the second is this, a wireless Nano USB adapter. Now we require our sensor, that is humidity and temperature sensor SI7006-A20, and this here is a connecting cable. Now make the connection among the sensor and the cable, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly to the ground of I2C Shield. So we are done with the hardware connections. So after that we need to interface the code, and let's proceed. Now in the interfacing part, first of all we need to log in to github.com, and after that we need to search for the repository that will be control everything community. And here we go, and this comes the sensor SI7006-A20. This is the C code, but before that let's go to the instructions part, where we need to set up the BeagleBone Black as you can see on my screen, and this link beaglebone.org is the link from where we need to follow the instructions carefully for the proper setup. After that we need to download or git pull the BeagleBone Black or the code on that after that, and this is the command for the compilation of C code, and this will run the C code. Please note it down. Now we have the C code as you can see on my screen. It's a .c extension file. We have included some of the header files in the code, some libraries here, and the void main function. We are going to check whether the I2C bus is going to open or not, and the address of the sensor that is connected, that will be 0x40. Now in the writing part, we are going to send humidity measurement command no hold master mode, that will be 0xF5, and then we are going to read 2 bytes of humidity data. It's a general read, and then we have the conversion of the data using the formula mentioned in the data sheet of this particular sensor. Then we are going to print the data onto the screen, which is the relative humidity in %RH. Coming to the second part, we are going to send temperature measurement command no hold master mode, that will be 0xF5, and then we are going to read 2 bytes of the temperature data, and it is also a general read. Then we are going to convert the data using the formula mentioned in the data sheet. And at last we have the output data onto the screen, which is the temperature in Celsius and Fahrenheit. So this is how the sensor is. Now let's see sensor code is. Now let's see how it works, the code and the practicality. Now for the working part, the first step we need to do is to copy the entire code. First of all, as you can see on my screen, copy it, and then we have to create a new file as you can see on my screen. This is the command SI7006, and .c will be the extension, and here we need to paste the entire code as you can see on my screen, and after that we need to save it. Then for the compilation step, this is the command .c is the file name, and let me type the correct name as you can see on my screen. .c is the file name, and then after we have this step, and the code is now being compiled successfully. And for the working part, this is the command we need to do. This is to run the code, and then we have the relative humidity in percentage RH, and we have the temperature in Celsius and Fahrenheit. When I again run it, you can see a very small change regarding the relative humidity and percentage and temperature in Celsius and Fahrenheit. But instead, when I try and apply a finger over the sensor and run the command, you can see the relative humidity and the temperature changes. When I again run the command, the change are reflected onto the screen, and here we are. So this is how the sensor responds. Now let's have a look over the working. We have seen the working now. Look over the applications and some of the benefits. SI7006-A20 and I2C Humidity and Temperature Sensor is a monolithic CMOS IC integrating humidity and temperature sensor elements and analog to digital converter, signal processing, calibration data, and an I2C interface. The patented use of industry standard low K polymeric dielectrics for sensing humidity enables the construction of low power monolithic CMOS sensor ICs with low drift and hysteresis and excellent long-term stability. These applications are like HVAC, thermostats, respiratory therapy, microenvironments, automotive, climate control and defogging, asset and good tracking, indoor weather stations, and a lot more. So these are the features which make a lot of applications like this. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubts regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.